Continuing with problem 6 from exam 25, we have already solved the first part, so now we're going to solve the probability that certain individuals have a single allele of X. Reading the question again, allele X is an X-linked recessive gene causing edema at low pressure. Mars is low pressure, so edema, presumably pulmonary edema, would be bad. All males in generation 1 are wild type for X. That's easy to remember. We won't even notate that. All females are wild type for A, but carriers of allele X. So, and I will notate that here. They are carriers of this allele. They're heterozygous. So I will use a single slash to keep track of that. Individuals 3-1 and 3-10 are wild type humans. They are not descendants of the original Martian colonists, so we have to keep track of that. We want to calculate the precise probability that these individuals have a single allele of X. So starting with individual 3-4, so generation 3, individual 4, we earlier calculated the probability she would have a single allele of A. Now we're going to do of X. And you might think, because it's a bit symmetric, that would be the same, but the sex linkage might complicate matters. So what we want to do is we want to know what gametes her parents can produce. So we need to know the genotypes of these two, so we know what kind of gametes, the frequency of gametes they produce. So let's look first at her father. Her father must have given her father, this is a sex-linked gene, so we have to keep track of it. So she inherited from her father a Y chromosome. So as far as allele X is concerned, she is either wild type or she is X, one or the other. 50% chance. He's also Y, but we don't need to concern ourselves with that. The female, on the other, her mother, on the other hand, is somewhat different. Her father must have given a wild type allele, sex chromosome, and the mother could have given either a wild type or X. So now I have to be careful because there is 2 here and 1 here. So let's go back to how we did it before. I'm going to tell you the answer. The answer is this. So let's be careful. I'll show you use the same Punnett square method. First for the father. So for individual 2-1, 2, 3, 4, 5, the father gives a Y chromosome to the son, and the mother can have a chance of wild type or a mutant, which means that the offspring here, the son, will be either plus Y or XY, equal probability. So what kind of gametes, equal probability of this. So all we care about is what kind of gametes he can produce. And he can produce then equal likelihood of 2Y, 1X, 1 wild type X, and 1 mutant X. We know the gender of the offspring all the way through the pedigree, so we can ignore the Y there and just focus on this. So equal chance of producing an X gamete with an X chromosome that's wild type or mutant. The mother is a little bit different. I'm going to write her here, and she is individual 2-6, and so in her case the father can produce only one kind of, because she's a daughter, the father produces a wild type X chromosome in the gamete he gives to her, and the mother has an equal chance of the wild type or the mutant X chromosome. So the likelihood is that one chance that she is wild type at X, and another chance that she is heterozygous for this recessive allele. So if we look at that, we can say the gamete she will produce will be 3 wild-type X chromosomes for one mutant X chromosome. That's different. So this problem is different than the questions here about inheriting this recessive X allele is different than the problem with the dominant A allele, because the sex linkage is affecting what the probability is, because we know the gender of the offspring. Okay, so we know that, and I've written that already up here, that I can say the proportion of gametes produced by each of these individuals is either wild type mutant or 3 chances of wild type, 1 of mutant. So the question now concerns individual 3-4. I'm going to put her down here. So individual 3-4. Individual 3-4 is female, so the father gives a X chromosome, so he has an equal chance of giving a wild type or a mutant, and the mother gives X chromosome, and there are 3 chances of a wild type and 1 chance of a mutant. And we use this Punnett square, divide it up like this, and we see there are 3 chances that she is wild type, 3 chances that she is heterozygous, another chance that she is heterozygous, and 1 chance that she is homozygous recessive for this recessive allele. So the probability is that she has a single allele of X. So we want this one and this one, and those are 4 chances out of a total of 3 plus 3 plus 1 plus 1, 8, so that's equal to 1/2. The simplest thing to do is to list it at 1/2.